You were given a mechanism in which there is a circular member here that's supported by a bar here at a point B, and there's a load applied here. This has a pin joint here, and there's a pin joint here. And so I set my origin at the center of this circle, so I can write position vectors to point A. And we know that this is 120 degrees here from that to this. So we have that position vector with the radius is r, and point B is right along the is at theta equals 90 degrees. So that's this vector, and point D is down here, and we were given some dimensions about the distance from where the length, the height, and the distance in the vertical and the horizontal directions for this bar, and I called those D1 and D2, and those are given in the problem. And then I defined a unit vector from D to B, so we could write this force. So the force in this member has a magnitude and a direction. And then the force at the we have the force at the reaction force at point C. And again, I guess I didn't write the vector to C, but the position vector to C, but that's just right below the origin here. So that would be 0 minus r, 0. And once we have all those, we can just say sum the forces and moments on this structure. And to get the, we just need this reaction force and this reaction force. So in fact, we don't even need, so we didn't really need to break it apart. So we just sum the forces on the whole structure. And we wind up with the force in this member is 375 newtons. In the x direction, we have minus 205 newtons, so this force is to this in this direction. And in the y, we have minus 360 newtons, so we have a force in this direction. So our reaction force is somewhere over like this.